Let's look at example 11 in your textbook. Part A is y equals ln of kx. And here k is a constant. So we want to know what is the derivative. Well, the derivative is, the numerator is the derivative of this function, which is k, divided by the function itself in the denominator, which is kx. Of course, those k's, k divided by k is just 1. They cancel. So this equals 1 over x as well. So special case, but still follows the basic rule. Part B, y equals ln 1 minus 3x. So the derivative is, in the denominator is just that function after the ln, and in the numerator is the derivative of that function, which is just negative 3. Of course, this is a little awkward, some negatives in there, so a better way to write this would be 3 over negative 1 minus 3x. The reason I'm doing this is because we can simplify. This is negative 1 plus 3x, which of course is better written as 3x subtract 1. All right, that's a long roundabout way of saying, hopefully you can just go directly from here to there and to say that those two things are equal, but this one is written in a better manner, more simplified. And C, y equals x cubed ln x. Okay, you can see here we're going to need to use the product rule. So let u equal x cubed and v equal ln x. So u dash will be 3x squared, v dash will be 1 over x. The derivative, u dash v plus u v dash. Fill in what we have calculated up here. And simplify. So 3x squared ln x plus x cubed over x. Okay, of course that can be simplified to x squared, and we can factor out an x squared, 3 ln x plus 1. Okay, let's recall our laws of logs. So reaching back into our brain to remember that the ln of AB equals the ln of A plus the ln of B. The ln of A divided by B is equal to ln A subtract ln B. And ln A to the power of n is equal to n ln A. Okay, so these rules will help us in simplifying expressions and functions so that we can more easily take the derivative of them. Example 12 in the book. A is y equals ln of x e to the power of negative x. Okay, so remember the rule for taking the derivative of a logarithmic function. The derivative is the derivative of that function just divided by the function itself. Okay, so we need to do that in this case. The derivative of this function. So the derivative of xe to the negative x over xe to the negative x. If you wanted to write that, you could. Of course, you can leave out this step. It's not really even a step. I just write it in there to remind us what we need to do. So here we need to do an additional step, though. We're going to need to use the product rule again. Okay, so with the product rule, let u equal x, so u dash is 1, v equals e to the negative x, so v dash equals e to the negative x times negative 1, so negative e to the negative x. All right, and then we're going to say u dash v plus u v dash, and I'm just going to fill that in here in our numerator instead of continuing it down here. Okay, so u dash is 1, v is e to the power of negative x, plus, this is the product rule, so it's plus, u, which is x, and v dash, which is negative e to the negative x, all over x, e to the negative x. And of course we need to simplify e to the negative x, subtract x, e to the negative x, all over x, e to the negative x. Now there must be more ways to simplify here. We can factor out e to the negative x. We'll have 1 minus x all over x e to the negative x. E to the negative x divided by e to the negative x equals 1. So 1 over x, 1 subtract x over x. Okay, another way of writing this, if you wish, is 1 over x minus x over x, better written as 1 over x subtract 1. Okay, this is correct as well, though. This is fine. Okay, another way of tackling this problem, and as we said before, that there's going to be more than one way of doing things. Because we know our laws of logs, we could actually change this to y equals ln x plus ln e to the negative x. And maybe this has less steps in it. We could take then the derivative, it's just using the addition law, the derivative of the first one is 1 over x, and the derivative of the second one is e to the negative x times negative 1, the derivative of that divided by itself. And simplifying, this equals 1 e to the negative x divided by e to the negative x. So 1 over x, subtract 1. So in that case, yes, it is quicker, as you can see, to use your laws of logs to simplify and then take the derivative. And part B, still example 12. Y equals ln of x squared divided by x plus 2, x subtract 3. Okay, so you could do this out a long way by using the quotient rule, and then in the denominator you'll also have to use the product rule, or we can use our laws of logs and simplify this a little bit. So we could say ln x squared subtract ln x plus 2 plus ln x minus 3. Okay, be careful how you are setting this up to make sure you don't end up with addition instead of subtraction. Okay, and now we can easily take the derivative of the first part of the function. Derivative of x squared is 2x over x squared. The derivative of x plus 2 is 1 over x plus 2. Derivative of x minus 3 is 1 over x minus 3. Okay, and we can simplify that first part, 2 over x, subtract 1 over x plus 2, subtract 1 over x minus 3. If you wanted to get a common denominator there and put everything together, then that would be fine as well.